My name is Scott Karinskis. I'm in the Platform Products Group at C3, and with me today is Shiva Somasundaram, also in the Products Group at C3, leading the C3 AI Datasets product. And so it's my pleasure to kind of give you the second introduction to what we're calling version 8. How many of you have been using C3 AI for more than a year? Cool. 2 years? 3 years? 10 years? Okay, so I guess I'm the odd man out here. So I've been with C3 going on 10 years, actually a little over 10 years at this point. And it's been a journey. It's been a journey to deliver V7. That was a product we delivered several years ago. And when we took a step back, going on about 4 years at this point, to think about what should our next generation platform look like? And we really wanted to build a platform that would last the next 10 years. And for me, it kind of boiled down into two key areas. And I focus on kind of the developer and the data science experience. The business, I hand off to Adrian and my applications PM team. And for the architects and the developers, it really is, how do we provide a better low-code, deep-code experience? Now, when I say that, I'm not talking just about making it easier to write code, giving you IDEs or giving you visual tools. It's all about how do I make getting access to environments faster and easier, making provisioning time or deployment times faster. How can I address issues with UI bundling and make them available so that as I'm editing my user experience, it's immediately available. So we wanted to take a step back and think about how can we make fundamental changes to the platform to make the developer and architect experience better. On the data science team, you guys are a vocal bunch. And AI is at the heart of every application we deliver. We have a pretty sizable team of data scientists at C3, led by Henrik, and they're very vocal too. But we wanted to make sure that we're providing the right experience for them, but also the right experience for you. And we received some very pointed feedback that I'm going to go through a little later. And so that market-leading data science experience to us is critical that we deliver. And from my very simplistic perspective, if I can meet the needs of the developers and the architects, I can make building applications faster and easier, and then as a result, I can enable our teams and your teams to deliver applications faster and cheaper. I have a very simple model. Now, we started this project about 4 years ago. And what you're seeing here are the actual screenshots of our Confluence page where the engineering team and the products team started to put down what's on the top of their mind. What do they think we need to do for a platform to last the next 10 years? And this runs the gamut from incremental type loading, which I will talk about, duck typing, anyone familiar? Okay. To improving performance, scalability, data ingest, security, and we went through a very lengthy process of basically scoring them and ranking them as far as importance and then priority. And we did this over a matter of probably a couple of months, and then the team finally picked a name for the project. Anyone guess what name they might have picked? Okay, fine. And this is true, unicorn. My daughter loved it. She was 10 years old at the time. She's like, that's a cool project, Dad. I'm like, yeah, I think I'm gonna have a hard time getting that past marketing. And of course, they're like, no, we're gonna call it version 8. I'm like, well, we are on version 7, so I guess that makes sense. And so, one of the things we did is we kind of looked internally about what problems we think we needed to solve. But we also have 10 plus years of feedback from our customers. Right? And so from a developer and architecture community, whether it's runtime costs, increasing performance, supporting better multi-tenancy or environment scalability, having a microservices architecture, we received a lot of feedback in this area. And I'm gonna pick on a few areas that I think probably set the foundation, and then there are numerous enhancements we can talk about later. But to me, it all starts with the type system. Right? Make no mistake, when we talk about model-driven architecture, it starts with the type system, it starts with the DSL, and the fact that we're writing metadata, not code, for a lot of our applications. And so we really had to think hard about how do we improve the performance of the type system. Right? The DSL, the syntax we liked, and we generally have received favorable feedback from our customers, but we knew we had to improve. And you told us we had to improve. So the ability to access or update types faster. Right? Provisioning times need to go from in the order of minutes to the order of seconds. Reduce the memory requirements of our servers. And this one's a little subtle, but if you look at how we manage memory internally, metadata is great, but if it's in our current format, it's good, but not great. When you touch a tag, we load all the metadata. You could be using 10% of the metadata, but we're still loading 100%. So we wanted to move from kind of we wanted to move from an interpretive model to a compiled model. So now every application's code, every time you author a type and you deploy it, it's going to be compiled to Java. That will reduce memory, that will improve performance. That, to us, is a fundamental change at the application layer. We've been doing that for years in the platform team, but we never did it to apps. The second is we're going to do incremental type loading. So we're only going to load the types the application accesses. Our estimates, we estimate that can reduce anywhere between, frankly, 30 to 70% of the memory. Because what we see is typically there's a core set of types that the application uses, but there's also a lot of types that they don't touch. So we wanted to kind of focus on performance, reducing memory. We also wanted to improve our ML performance, and specifically how we exchange data in a pipeline. So for those of you, I'm going technically here, but for those of you that, the platform is written in Java, but the majority of our data scientists are writing in Python. So schlepping data back and forth between Java and Python can be very expensive. I need to serialize, I need to deserialize, say a document, turn it to JSON, rehydrate it in Python. And if you're passing integers or doubles back and forth, who cares? If you're passing features for 3 years of historical data over 5 assets, that starts to consume a lot of time, a lot of memory. And so we actually looked at, how can we make this better? And we moved from kind of a serialization, deserialization model to using a technology called JEP, basically embedded Python and Java. So instead of passing documents back and forth, we're passing pointers back and forth, right? Now, there are going to be some limitations with that approach. Those objects are now immutable. But we hope that for the majority of our internal processing and data pipelines, that should actually dramatically speed up the performance of a pipeline. And lastly, and this one's been a thorn in my side for many, many years. We wanted to make getting access to environments and deploying environments faster and easier. How many here of you have like a tag or an application deployed in the development environment? How many of you had to wait a day or more for that tag to be available? Right. Yeah, in hindsight, not acceptable, right? So what we've done is, and just for those of you that are maybe a little newer to C3, it's a process. And some of this process is C3, some of this process is our operations or your IT organization. But it starts with creating an environment. That's a fact of life. I always have to stand up the infrastructure to host the applications. Whether that's a VM or a Kubernetes, doesn't really matter. But then I need to deploy an app, I need to create a tenant and a tag. I need to configure package manager, because if I'm deploying reliability, I have to pull the reliability package from somewhere. I have to configure single sign-on, how else are users going to authenticate to the application. I then need to register the application with my DNS. This is probably the most sticky part of all of this process. And then finally, I can deploy the application. Sometimes that can happen in minutes with the right configuration. If you let C3 manage the DNS for you and so on. But in most environments that I deal with, deploying your first app is typically on a good day, hours, on a bad day, multi-day process. And you think about it in production, you're like, fine. I deploy an application every 6 months, every quarter. I can burn a couple days. But think about those poor developers that you're trying to onboard, and now they're like, okay, I just joined the project, and I'm now going to wait 3 days for an environment to magically appear. Not acceptable. Now, which means if I do it again, it's going to another 3 days, rinse, lather, repeat. And to be fair, there are limits. Now, I'm a firm believer there are limits in everything. But there are hard limits or quasi-hard limits in the number of applications you can have in a given C3 cluster environment. And that, depending upon the application, ranges around 10 to 15, depending upon the size and scope of the application. So if you're an ISV out there, and I've talked to many of our partners like FIS and others, they want to deploy applications not to one customer, not to two customers, but to hundreds of customers. This model becomes very problematic very quickly. And so what we've done, and we've started the migration to Kubernetes. Some of you are aware of it. But to me, Kubernetes it's the enabler. It's not the solution. The solution to me was really rethinking how do we deploy applications and how do we eliminate a lot of those hurdles? How can we make sharing the package manager configuration across applications easier? How can I configure the single sign-on integration once and again share it across the application stack? So that once the infrastructure is created and I've done my basic configuration, I literally have one line of code or one click of a button if you're in AI Studio to deploy an application. And if I'm deploying the first application, it takes, depending upon hardware, it might take a minute, might take 5 minutes if on a bad day. If I want to stand up another application, it might take another minute, another 5 minutes. Because basically, by the time you get to application 2, the only human that's in the loop is the person that starts the application. Don't call ops, don't call your IT, basically just talk to C3. And the other thing that's kind of very subtle in this slide is you'll notice that application 1 and application 2 have their own databases. If I go back to this slide, you'll notice that generally applications share a single data store. And that works great. Don't get me wrong, sharing cost, but if you have one application that's tiny and you have one application that's consuming a lot of resources, you start to hit the noisy neighbor effect. And so by moving to this model, we've basically now, you have control over the resources dedicated to each and every application. Not only the compute, but also the storage. So if you want applications to share a database, cool. If you know you're going to onboard an application that has a very different profile and a very different data size than all your other applications, you can elect to just dedicate databases just to that one application. But it's no longer a one-size-fits-all approach. And that's both at the data tier and the compute tier as well. Okay? So, and as a result of this, right, I think if we don't address the faster application deployment story, well, I probably won't be here next year. I think it's that important. I really do. The days of me acting as the intermediary to ops to deploy an application have to end. I think the ability to share or isolate resources across your applications can fundamentally change the way in which your budgets are managed. In my experience, every application comes with a budget, or it should come with a budget. And some of our customers are very strict about this, others are less strict. But by having this, by giving you the control, you now have the capability of controlling where the dollars are spent and how they're spent. It's not just I'm going to spin up the biggest worker because some application requires it. That goes to cost management. And lastly, and this is probably one of the most requested enhancements that I've received over the past couple of years, is the ability to stop and start applications. Today, you start them, they're up. You can't really turn them off. You can delete a tag, but that's not quite the same thing. And so now as a result, you can define policies. Maybe I want to stop my applications every night at 11 p.m. and resume them at 8 a.m. I want to turn them off over the weekends or holidays. We have techniques to solve this problem in V7. They've been deployed sparingly, and they require our operations and your IT teams to be heavily involved. Now, let you define the schedule and let you set it and enforce it. Okay, so that's kind of on the infrastructure side. We continue to make investments and improvements in our deep code, low code, and no code experience. I'm going to focus primarily on deep code and low code. No code is the ex machina session. So from a deep code and low code, we are true believers in both models. And we are true believers that it's not a one size fits all. There are people, maybe here, if not your teams back at home, that want to write code. You give them a visual tool, they'll be like, thank you very much, but give me my IDE. Yet they probably have other people that would be quite happy to point and click and configure applications that way. So we do believe we want to tailor the development experience to both personas. And I'd say the other fundamental change, and it's not just naming, but we want the AI Studio to be the experience for all personas to the platform. It's not just a development experience, right? Developers they're 1/3, if you will, of the population I think of. All right, it's great that they can develop apps, but if we're not providing the right access to tools for our data science organizations, they're not going to be super happy. So the ability to access the tools that are available to the data science teams will be available through AI Studio. Configure the user experience. And then also, I'd say DevSecOps has been a kind of unsung experience in my mind. And if you're an IDS user today, I suspect that the majority of you are using it to view the state of your builds and test results and determine if I want to promote a build from dev to QA to prod. That's critically important. But where we also need to go moving forward is, what about the operations? I mean, it's not just about building apps. I need to operate them. I need to change the hardware profiles. I need to modify the configurations from time to time. And so we want to provide a much better experience than what we've provided in the past, AKA console. And so Canvas becomes the experience to configure applications, or I would say it becomes the experience to navigate and then configure your applications. VS Code continues to be enhanced. So we've had a VS Code extension since V7. We continue to enhance the VS Code extension in V8. And really the big enhancements are the ability to write and manage tests. So for those of you that maybe have had to write a test on C3, you write your code, you drop it in the console, find a bug, you go back to your authoring environment, drop it again in console, kind of a disjoint experience. So now we want to provide a single experience where you can write the code, test the code, and deploy the code. We continue to enhance UI Designer so that you could, we provide a lighter weight experience. So if you like the look and feel of C3 applications, you like our components and our component library, we want a declarative configuration experience. If you want to enhance it, that's great, but now you're going to go to code. If you want to customize or extend the component, perfect. But that will require an additional skill set. And then lastly, DevOps Studio to build, manage, and deploy your applications. So these are, so again, we're trying to think of AI Studio as not just a development tool, but a data science starting point, and an operations tool. So the other area of feedback I've been receiving quite a bit these days from the developer and architect community really is around, I'd lump it under the leverage existing investments. Most of those investments are in the form of some sort of data or data product. Whether you're a customer using Delta Lake or Databricks, Snowflake, you have OSI Pi, you're using SAP. Many of you have made significant investments in data products, and you want to be able to reuse them across your portfolio of applications. And that typically looks something like this. So my job and my team's job, in many ways, is to help you and help our applications better, to play nicely with the data lakes or the databases you're putting in place. And so I've spent quite a bit of time talking with organizations about Databricks, Snowflake, Azure Synapse, and BigQuery. And I see us continuing to invest, and in some ways actually maybe making more investments to be a better citizen, if you will, with these data sources, other than just building a connector. Connector is the first step. We have connectivity, we can read and write, cool. But what happens if I want to carve out a section of my energy management application and I want it to actually run on Snowflake? That's where I want us to go, to give our applications more flexibility to run on third-party databases. So that's the data science, that's the application developer experience. And to be fair, I'm not doing all the work we've done full justice, but these are kind of the highlights for today. Now, on the data science side, there really have been 2 or 3 enhancements that really come to mind. The first, where we started V8, the goal was, how do I better enable experimentation and prototyping to production? How do I make it easier to experiment on the platform? I think coupled with that is how do I allow data scientists to better or more easily onboard to C3? And when I say onboard, I'm really saying, I don't want to have to spend 2 weeks in training to be a data scientist on C3. I just want to take the knowledge I have, pandas, Python, machine learning algorithms, and I just want to apply it to C3. I'm willing to learn the type system, but it can't be a type system first experience to say, let me get productive and then gradually learn more and more about the type system, features, metrics, and so on. And so a lot of the work that Shiva has been doing, that Jake has been doing, and Henrik's team has been assisting in is really to help improve the data science onboarding experience. And that experience starts with Jupyter Lab. Right? We've supported Jupyter Notebooks for many years now. We are moving kind of to Jupyter Lab as the next evolution of Jupyter. You still have access to your notebooks, your models, your pipelines. Now you can manage your runtimes, better manage your libraries and services you may integrate with. And one of the interesting things that, I'm going to get myself into trouble, but one of the interesting things about Jupyter Lab is its extensibility. So to be clear, we're going to go with vanilla Jupyter, or Jupyter Lab. But given the fact that it has a nice extensible framework, it gives us a lot of opportunity to maybe, to add more widgets, I think that's what they're called, to the Jupyter Lab experience. I don't know what that means yet, but one of the things that drew us to it was its extensibility. If there's one area where I'd say we probably had a huge investment and really kind of set the foundation, the second foundation for a lot of the data science work is what we call data sets. The goal of data sets is to provide what I think of as a Python-first experience. With data sets, I can open up my Jupyter Lab notebook. I don't need to know about the type system. I don't need to know about metrics. I don't need to know about data integration, source types, canonical types. I can just go right to data sets, and I can start using the knowledge I have to explore data, prepare data, develop my models, develop my features, and eventually maybe productionize them. And the way we've done that is we've actually implemented, we've kind of moved beyond the confines of a Jupyter notebook. And under the covers, we are using distributed technology to basically give us a distributed infrastructure on top of pandas. That is kind of the foundation. So you're not bound by just your Jupyter notebook, but we now can distribute that across multiple nodes, and we can have parallelism in the execution, a lot of some of the work that is done. That sets the foundation. But really, where things come together is when we talk about, I've done all this work in a notebook, I've read a CSV, I've transformed some data frames. I'm not a data scientist, so I apologize. I've wrangled some data, and I want to preserve that work. I don't want to have to then go walk down the hallway and talk to a data engineer to say, well, here's all the work I did to kind of make this work. And so now within data sets, we can generate that metadata for you. We'll take the work you've done in your Python notebook. We'll create the C3 metadata that can then be handed off to an application developer or some other persona to then extend. So we're giving the data scientists the experience they want, but we're also preserving all the work they do and enable it to contribute it to a C3 application. Another area of investment in V8 is what we're calling feature store. Now I could make a case and say, well, we had a version of a feature store in V7. We have the feature metadata, we just happen to call them metrics, not features. And I could go toe-to-toe in any argument on that one. But what we heard from customers is, A, if I'm a data scientist, first of all, nomenclature gap, they're called features. So let's embrace the terminology. Second, we want to add support for time series and non-time series features. We've always been a time series first type organization. We love time series. We can treat anything like a time series. Until a data scientist said, well, wait a minute, this feature's not really time series. Then we had some kludgy workarounds. And that we also kind of, in V7, you had pipelines, you had data going into the pipeline, but the concept of a feature, it was there, but it was a bit obscure. And so now we want to provide a much more cleaner, much more obvious view of ML features, the relationships to models, training data, and the ML subjects that are eventually trained and inferred on. And then finally, we are going to be persisting. So basically, you think of our time series or metrics are now going to be persisted. Now, you can make a case in V7, we had metric caching. That's persisting a feature. But it required you to manage the persistence. It required you to manage when are they updated? How are they updated? When are they invalidated? We kind of want to eliminate those barriers. So look, we will provide the feature store, you define the features, and leave it to us to keep them up to date. And since they're persisted, you now have more repeatability, and hopefully you'll have improved performance. Oh, and by the way, all the work you do to define features in pandas will also be generated as features from data sets as well. And Jake will be showing that to you tomorrow. Lastly, we continue to invest in ML pipelines. They are central to our overall ML strategy. They are the backbone for everything we do around machine learning. And so what we heard is people love the concept, but we needed to make them a little simpler. So in V8, the amount of code you need to write to use a pipeline goes down by an order of magnitude. If you're, basically we can also convert Python code. So if I'm using a scikit-learn pipe, I can convert that to a C3 pipeline. I don't need to create a wrapper around scikit-learn to do the same thing. So again, minimizing the additional code that you need to write. And then lastly, features can be declared in a pipeline themselves. So, and Jake will go much longer tomorrow in his data science on C3 session. So what I want to do now, I've got Shiva here. We want to give you a preview of data sets and Visual Studio Code, some of the work we've been doing in the context of V8. Shiva's going to play the role of a data scientist. He's been handed a new data set, and he wants to do some wrangling. And then hopefully, I'll be able to look at the work he's done and see how I can apply that to an application. So Shiva?
Good afternoon, everyone. Can you guys hear me? Cool. So I'm going to try and do a live demo, so let's pray that the demo gods are with us today. This diagram that you see here, this is pretty much the life cycle that every project has to go through before you can call it an AI application that can run in production, at scale. The challenge here is if you look at this pipeline or the workflow, there are multiple personas who work on every stage of this pipeline. And the requirements of these personas on each of these stages could be very different. Above and beyond, the whole story with V8 has been, we want to improve the developer experience. And we want to improve the developer experience for every persona in this workflow. That means a data scientist, a data engineer, and an application developer. So what is it that they want? Well, they all want to be able to use the tool of their choice, because that's how they can get going immediately. They all want to be able to run at scale, and they don't want any throwaway work as an organization. As Scott put it, I need to be able to do my work, and everything that I did and the time I spent needs to translate to work that he can pick up and move forward with. And back in school, I grew up writing pandas in Python. To know that pandas own work for data over 1 gig, to know that pandas cannot be the thing that I can have for the rest of my life was the adult version of Santa Claus is not real, right? So, but what if we could solve that problem, right? What if you could do all of this in pandas, and then at the click of a button, or to be more precise, with just one function call, have that all converted to software artifacts which you could use to build an application that can run and scale. Can you do that? With V8, yes, you may. That's the answer.
And just to kind of summarize what we did, right, we read the CSV into Jupyter Lab. Jiva did data preparation. He generated or created the metadata. He did it all in pandas. Did anyone see it other than at the end, a C3 type file, the C3 API? So he used the knowledge he had to basically create C3 artifacts, and as what he generated will work. You could take that data and you could immediately start loading that data. I thought about doing that today, but I figured watching data load is kind of like watching paint dry. So I would spare you the time. And yes, in this demo, he did it in the span of about 10 minutes. My suspicion is if you took someone that had just finished training, they might have been able to go through that process and create all the artifacts that are correct in probably a couple of hours or more. So again, we're trying to provide the right experience to the right user and improve productivity. To summarize, so it has been really a pleasure to introduce you the second time to version 8. We're at the start of our V8 journey. I'll be honest with you. Right? We wanted to make sure we had functional parity with version 7, but we have much bigger aspirations that I look forward to talking to you next year about. And we really, the focus has been on the experience, both at the UI or the glass level, but also in kind of the APIs and the knowledge level. So whether that's providing a low-code experience through AI Studio, making application deployment and metadata authoring easier through low-code or deep code tools, or providing better compatibility with your existing infrastructure, that was one clear theme. On the data science side, clearly making it easier to onboard and supporting the languages and tools of choice were critical. And from my very simple perspective, if my team and my engineering team deliver 1 and 2, I think our application development teams and your application development teams will benefit. With that, let's open it to questions. Yes, back row.
As a data scientist, if I want to fetch data from, say, Cassandra,
yes.
Can I do it natively in Python now?
Interesting question. So the question is, if there's data in Cassandra, can they fetch data directly from Python? So for data that's been ingested through C3, you'll still need to go through the type system. Paul, did you have a question?
Well, yeah, I wanted to ask, when you did the package update, was there a provision? There was actually a provision there?
Yes. We actually deployed the metadata to the environment.
That was pretty fast.
That's the goal.
So, I mean, the operations that I did and everything, there were very few, right? If we can go back to the diagram, I had data operations, feature engineering, ML pipeline, and then operationalizing an application. I just picked very few operations at the very beginning because the goal here was to actually show how we could transfer everything to application development. But if you're interested in how you could do everything in Pandas, check out Jake's session tomorrow. We're going to spend a lot of time in a notebook, and you will see this, that it's not being as fast as it is here today because of that. But that's the smartness of the system, to be able to differentiate what is data engineering, what is feature engineering, and create the right artifacts for that.
Yeah. Cool. Yes, the back.
I was surprised by that slide that you showed dedicated databases.
Yep.
It seems like counterintuitive versus like what it looked like with Kubernetes. And what? I'm just curious, what's the Is it that it doesn't work well enough that even if you have good distribution of compute and everything, you still hit a wall, you still get that? Or what is it?
So, yeah, I mean, so I think the question is like, why, I mean, keep me honest, what would drive someone to want to create another set of databases for another application?
Yeah, if you're doing well, you distribute the tasks and
Yeah.
and everything.
Right. So if your application deployments are fine and your database and the database performance is perfectly fine, there's no reason to add another one. Now there are cases where, I mean, I've seen this in kind of like in the financial services world and the healthcare world, where frankly there is almost a mandate where it's like, as much as we talk about logical separation, from a data perspective, they want physical separation. So that's one reason. Another reason could be just, these are finite resources, right? I mean, I'll be clear. I mean, Postgres can scale well, but it has limits. Cassandra scales well, but do you want a 192 node Cassandra ring? I have one of those in production right now. I would argue if we could avoid that, that would make everyone's life much better, especially one ops engineer in Redwood City right now. So the ability to, I mean, so again, this is optional, but it's also, it gives you the flexibility to say, look, if I'm going to onboard a net new application that's going to bring in 5 terabytes of data, okay, I can share. If it's 20 terabytes of data, it's like, hold on, let's talk. So it's an option. It's not a mandatory requirement. Okay, anything else? Thank you very much. Oh, wait, we had one straggler. Yes.
So does this mean that you can basically spin up individual user ephemeral clusters? Right? Or what does that mean?
So what it means is you can spin up user ephemeral applications, and yes, you could stop and start them. Okay, that's that. Thank you very much.